Hi, class. Today we are going to see something about phosphate solubilizing microorganisms. This will be the last part of this biofertilizer. So, first of all, let me tell you what are phosphate solubilizing microorganisms. So, as the name itself indicates, these phosphorus solubilizing bacteria and fungi uh, have the capacity to convert the insoluble phosphatic compound, such as rock phosphate or bone meal or cheaper sources of phosphorus, right, into the available form to the plant so that the plant can take up the phosphorus and it can use the phosphorus in its growth activities. Fine. So these are all particularly called as rhizobacteria because they're all associated with plant rhizosphere. These are called rhizobacteria. So they are very, very important in terms of the requirement of phosphorus to the plant. Many fungi and bacteria are potential solubles of bound phosphate. So they do this activity through secretion of organic acid. Therefore, phosphate dissolving soil organisms play some part in correcting phosphorus deficiency in plantation soil. They may also release soluble inorganic phosphate into the soil through decomposition of the phosphate rich organic compounds. These microbial inoculants can substitute almost 20 to 25% of the phosphorus requirement of plants. There are lots of other benefits which I am going to tell you about these things. Let us see, first of all, the salient features of these solubilizing microorganisms. Commonly, they are called phosphate solubilizers or phosphobacteria or even microphos. So, if they ask what are microphos, you should not be confused. They secrete organic acids like formic acid, acetic acid, succinic acid, glyoxylic acid, pyruvic acid, malic acid, etc. etc. As I said, 20 to 25% will be increased. Then average yield is 200 to 500 kg per hectare increase. We can see phosphobacteria are suitable for neutral to alkaline soil, while the phosphofungi are very very suitable for acidic soil. These produce growth promoting hormones such as auxins and gibberellins. If you would like to have a look of what are the bacteria and fungi which are having the capacity of solubilizing the phosphorus is Bacillus, many species like Megatherium subtilis, etc. Alkaligens, Orthobacter, Irvinia, Acinetobacter, then Pseudomonas also a couple of species, Flavobacterium, Serratia, these are all the bacteria which are phosphate solubilizers. PSM, generally these are called PSM, phosphate solubilizing microorganisms. Fungi, Aspergillus, various species, then Penicillium also is found to be phosphate solubilizer. What are the key functions of this phosphorus? It is mainly required for cell division and developmental activities of the cell. Then photosynthesis, it is involved. Breakdown of sugar, energy transfer, and nutrient transfer within the plant, phosphorus is required. Benefits the plants by deep rooting and optimum crop yield, increasing it. 0.1% of 0.05% phosphorus is available to the plants here. In which forms the phosphorus are all available, made available to the plants are orthophosphate, phosphine, phosphonates, even insoluble inorganic phosphorus in primary and secondary form, that is orthophosphate tri or dicalcium phosphate, hydroxy hydroxyapatite, and rock phosphate. In insoluble inorganic phosphorus are phospholipids, nucleic acid, and phytin. How to isolate them? Since I told they are all associated with the rhizosphere, we have to take the rhizosphere soil, then sterile water blanks, we have to dissolve that. Dilution is made and then plating is done. Incubate it at 28 degrees centigrade for 2 weeks. Transparent zones around the colonies you can see. And what is the media used for this? Picoskias medium is used wherein glucose, calcium, phosphate, then ammonium phosphate, KCl, magnesium sulfate, manganese sulfate, iron sulfate along with the yeast extract is used. Take a look at Picoskias medium which is used for PSM. Mass cultivation, the selected colonies, transparent colonies looking on the medium are taken. Then again on the Picoscias medium, it is plated. It is or taken in the culture, that is broth, 15 days at 28 degrees centigrade. Then from there, the starter culture is taken, that is 1 liter per 100 liter, fed into bioreactor, incubate for 7 to 17 days. It may vary at 28 degrees centigrade, and then harvest the cells at 10 power 8 cells per ml. So, coming to the carriers for phosphobacteria, wood, charcoal, peat, powdered, neutralized, sterilized 40% moisture and cured for 1 week. All these are powdered, neutralized, sterilized for 40% moisture. Sterilized and 40% moisture should be retained to hold back the phosphorus soluble microorganisms. Coming to packaging, LDPE is used, 200 grams per packet is packed, and they are stored preferably at 15 to 20 degrees centigrade. Fine. Then how to apply it on the field? These PSMs are taken, that is microphos, as I said, they are also called as microphos, are taken with water and with gum arabic, which will act as a adhesive, then added with calcium carbonate and made a slurry for the of that. Seeds are soaked in this slurry and dried in shade. They are all dried in shade, and then these dried seeds are sown in the field. Okay, so this is how the field application is done in case of phosphate solubilizing microorganisms. So coming to the advantages of PSMs, these encourage early root development. So much before the uh, scheduled period, you can actually have the root development in the plant. These increases the compatibility of the other beneficial microbes with the plant. They all produce, the microbes produce organic acids like malic acid, succinic acid, and fumaric acid, etc. Stimulates formation of fat and convertible starches in the plant body. Helps in rapid cell development in the plants and consequently increases the resistance towards few diseases also. Phosphorus is applied to ensure good symbiotic performance and overall plant growth. Enhancing phosphorus availability to crop through PSBs, phosphate solubilizing bacteria, holds a greater promise in enhancing growth and yield of lentils. Now, you might be wondering how the mode of action of phosphate solubilizing microorganisms, just to mention, is there are two schools of thought. One advocates that the solubilization by production of organic acid happens, and the other school of thought is always thinking that solubilization by action of phosphate phosphatase enzyme acts. Okay, so these are the two methods wherein the action of these PSMs are thought of and the advantages. So these are, and also states that fungi are reported to be more efficient phosphate solubilizers as compared to bacteria, actinomycetes, and cyanobacter. So this is how we cultivate the phosphorus solubilizing microorganisms and use them. So here we come to an end of the biofertilizers, wherein we have studied about the bacteria, we have studied about the uh, isolation, then mass production, then field application, packaging, carriers used, all these things. The possibility of all these being asked as individual organisms for 15 marks is there. So once it is asked for 15 marks, you have to write down right from the isolation to the method of application, complete including the media components, or else in general the biofertilizers can be asked, the production in general it can be asked, so you can put down the flow chart and explain what are all the process in the mass production, and the advantages over the chemical fertilizers can also be asked for the short notes, or the organisms individually can be asked in the short notes to comment on in 5 marks category. So if you go through the PPTs, taking a little bit more of your time, you will get all the flow charts, you will get all the information regarding the carrier, mass production, media, etc. So here we end the class of biofertilizer. Thank you.